Hello, my name is Darwin Chang, and I'll be showing you today how to create panel C for the sample summary PDF. I'll be doing this with patient 10 right back 8. So first you want to make sure that you have R and RStudio installed. Once that's done, open up this R packages install.rmd under mutation burden, sequencing data, and match mutation list scripts. In this file, you will want to press the play button. If you do not see the play button, then simply select all lines within this chunk and press Command Enter. I've already done this, so let's continue. You then want to open up the variance stripchart.r script from the same folder that we just navigated to. And then you want to open up Terminal. If you do not know where Terminal is, simply navigate to Applications, Utilities, and the Terminal app. Okay. So first you want to drag the R script, variant strip chart. Then want to navigate to the sample that you're looking for. So in my case, right back 8, patient 10, exome. Take the Excel file as your second input and simply press Enter. Okay, it's done. You then see that we have a brand new strip chart created. Open this up in Adobe Illustrator. Kind of just glance at it, make sure it's good. Take the box, copy paste, try and align it, make sure it's like approximately the same height. Take the y-axis values, and the x-axis values, and copy and paste them. If you do not already have a targeted gene panel already there, you can simply copy from an existing template. You then want to take the last 4 columns and align them, kind of separated from the first 6. Grab this line, put it in the middle, kind of in between. Then take this title. If you're working with UCSF 500, label the title of the strip chart targeted gene panel. For my case with exome, we're going to label this exome plus UTR panel. We're almost done. So you then want to take this text box and simply put it in approximately the same place. And then we need to fill in this text box. So first you want to go back to the terminal and check the first value that was written here. You'll see the number 940 for me. That's the number of mutations that were either validated or inferred in the Excel. So we want to replace the existing number, and then in order to calculate specificity and sensitivity, we need to open up the respective Excel. I'll just freeze panes to make this easier for you. You then want to scroll down to the peak of the ROC curve, or essentially where mutations and artifacts kind of collide. You want to take the lowest mutation value for specificity and sensitivity, multiply that by 100 to get percentage, and simply just copy and paste into their respective values. Rounds up to 92, and specificity is already already 100%. Then in order to calculate mutation burden, you need to navigate back to the sample summary, Excel, and go to the corresponding sample. As you can see, we have the footprints value labeled here, but not the number of mutations. So we need to take this number of mutations, 940, and divide it by the footprints value, which is essentially the number of base pairs that have over, I believe it's 6x coverage, 6x or more coverage. So in order to calculate mutation burden, which in our case is mutations per megabase, you take the number of mutations, divide it by the number of bases, and within parentheses, divide the number of bases callable by 1 million. We then get this number, 14.73, and replace the existing number. And that's how you do it. In case you have any questions on how to create the strip chart or kind of modify it at all, in case you want to make the circle smaller, these circles, go to this line, go to the far right, and go to CEX equals 0.3, modify that. If you want to make it smaller or bigger, just increase or decrease or increase the number. Okay, I'm saving it as an AI file, and I'll just save it as a PDF right after this. But one last thing, if you have any pathogenic mutations, you just want to zoom in on the approximate math of the pathogenic mutation, right-click whatever you just randomly clicked, bring it to the front, change the colors to either red or orange, depending on if it was probably or possibly pathogenic. Let's just do this for your sake. So kind of becomes like this red dot if it's probably, or it'll be orange if it's possibly. Just make sure that, for example, if this sample was, let's just say this variant was pathogenic, we just kind of go through, see if it was clonal, see if it was expressed. It's not. It is also in though, so you would go into the also in column, kind of pick like a matching variant, approximately around the same math. And then since it's got a validated call, we'll put in the validated column. So you'll kind of do the same thing. And that should be it. Thanks for watching.